just Screencastify. All right, while we're waiting on Jonathan. Okay, we're going to first start with this green paper, the solve by graphing. It's going to go on page 44. Good. Okay, so remember when we did graphing, it's back. Okay, so we talked about this briefly before. It's probably somewhere in this notebook. But do you remember what all the different names for a solution to a quadratic is? There were 4 of them. One of them is solutions. Anybody remember any of the other ones? Yes.
They're like, oh, no,
You're going to say what?
like 0.
Yep. Zeros. Yes.
Unidentified.
I don't think so. X-intercepts. X-intercepts. And then the other one is roots. So we have zeros, x-intercepts, and roots. So if you have a graph and you're asked to find the solutions, where are you looking? You're looking on the x-axis to find those x-intercepts. So on question 1 right here, what are my 2 x-intercepts, or my 2 solutions? 0 and? Yep. So x equals 0 and x equals -4 are my 2 solutions. Okay, well, look at the second one. Where are my x-intercepts on that one? There's not any. So there are no real solutions, which means we have 2 imaginary solutions. And if the solutions are imaginary, you have to solve them a different way. We're not going to find them from the graph. Okay, what about the third one? How many solutions do I have? Just 1. And what is it? 1. Because it only touches or crosses the x-axis 1 time. So when you have the graph, it's really easy. Nothing's too crazy. Okay, so let's flip this over. It says, draw a quadratic that matches the following descriptions. Okay, so our description of our graph is that it has a maximum and it has 1 real solution. Well, if it only has 1 real solution, what do we know about the graph? There's only 1 x-intercept, okay? What does it look like if it has a maximum? It's upside down. Lots of you did the arc with your hands. Okay, so the graph is upside down and it's going to touch your x-axis 1 time, meaning your vertex is on the x-axis. Okay, so it can be anywhere you want to. I'm going to put mine right here. And it doesn't have to be specific. You're just sketching what it would look like if it has a maximum and one real solution. Okay, so go ahead and do those next two. Okay, on part B, if it has a minimum, that means your parabola opens up. If it has no real solutions, that means it's not going to cross your x-axis at all. So you want it to open up above the x-axis somewhere. Does not have to be in the center like this. You could have put it on the side, wherever, just as long as it opens up and it's above the x-axis. On the last one, what does a vertical stretch do to your graph? A vertical stretch is going to make it really skinny, right? So it's going to make it really tall and skinny. So it has two real solutions. So what does it do with your x-axis? It's going to cross twice, and it's going to be really tall and skinny. So I made mine look like this. As long as it crosses the x-axis twice, and as long and skinny, it's good. Okay, so on this right side of your paper, it says find all the zeros of each function by using the graph. Well, they didn't give us the graph this time. That means you get to graph them, okay? You've already learned that. So I'm going to give you 10 minutes to work with the people around you, using your notes, using your notebook, to remember how to graph quadratic functions, using your notes and your neighbors. And you're going to graph these right here. Okay, as you're working with your neighbors, work with the people who are in a 6 feet window so we don't have to quarantine extra people. Okay, so we're going to take 10 minutes for that. Welcome. Okay, here are the first two. Okay, I did not show all of the work. Wait, what?
Oh, God, oh, no. Oh, God, yeah, no, that's, actually, I got the axis of symmetry right.
You got the y-intercept what?
I got the axis.
Yeah. The y-intercept is going to be negative 25, which is way down here off the graph.
Wow.
Okay. So yes, the first one was crazy because the vertex was off the graph and it was a fraction and all the things, right? But what are we looking for on these graphs? The zeros. What? How do we find the zeros easily? Or what's... I'm trying to think how to say this without giving you the answer. So we graphed a certain way, and when we graphed that way, we found the zeros first. Do you remember how we did that? Nope.
Standard form.
Nope. What's the other one? Factored form. We factored it. Okay, whenever you factored it, then it was really easy to find the zeros. Because the first thing you did was factor it, and then you set each factor equal to 0, and that gave you your x-intercepts. So like on this first one, if I factored it, I'd have 2 times x squared plus 7x plus 6. What are factors of 6 that add to give me 7? So that would make this x plus 1 times x plus 6. Right? And then you can set each factor equal to 0. Which gives you your 2 x-intercepts. Which means you just found your zeros without graphing them. But you had to graph it because it said using the graph.
Wow.
Okay, but if you had just graphed it, then you could have found those points where it crosses the x-axis, and those are your x-intercepts.
Yeah, I really forgot to divide the 12 and then I could have solved it all. That was okay.
You forgot to take the 2 out of the 12.
Yeah.
That'll get you. Yeah, that'll get you. Okay, on the next one, your axis of symmetry should have been -5. When you plug that in, you get your vertex is the point -5, 0. And then you find some other points, right? Are you making that face, Brian? The axis of symmetry is that formula x equals -b over 2a. Okay, so that would make it +10 over 2 times -1. +10 divided by -2 is -5. And if you plug that in with all the things, you get 0. Okay, but somebody I heard factored this one. You factor out a 1, you have x, or a -1, sorry, you get x squared plus 10x plus 25. And then factors of 25 that add to give you 10. 5 and 5. So this factors -1 times x plus 5 squared.
Oh.
Okay, that's vertex form. Tells you that your graph moves to the left 5 and reflects over. So you could have graphed it that way if you didn't want to do standard form. Okay, but then this also tells you that you have a 0 right here, your vertex, at x equals -5, because that's the point where it crosses the x-axis. On the third one, you had to do standard form because there's not any factors of 7 that add to give you 4. Unfortunately, yep. So you had to find the axis of symmetry, plug that in to get your vertex, and then find some other points. Yep, lots of numbers on that one.
Wait.
Okay, but when you graph it, does it cross your x-axis? Do you have any zeros? No, so this one has no real solutions. So on your assignment tonight, there's 3 graphs. And you do need to graph them, but remember the focus is for you to find the zeros. So I recommend starting by factoring if you can, because when you graph by factoring, you already get the zeros and the rest of it is easier. Okay? So again, this one folds in half and goes on page 44.
But this movie was dividing his leg. I don't like his leg. Look at this moon. Dividing his leg.
Okay, this next one is solve by factoring. And let me just reiterate, you already know how to do this. We did this when we were graphing by factoring. Yep. Okay. We factored for like 3 whole weeks, and then we graphed by factoring, and now we're gonna factor some more. Okay, remember that whole you need to be able to factor to do well in Algebra 2? Here we are. Okay, so that whole factoring is gonna come back to haunt you. Here we are, it's haunting you again, okay? For the sake of time, I'm actually gonna skip this front part. I'm gonna show you this right here, because this is what you already did. You already know how to do this. Set the equation equal to 0, factor the quadratic expression, set each factor equal to 0, and solve for x. This is exactly what we did when we did graphing by factoring. You've already done this. Don't panic. I see some panic in your eyeballs. Don't panic. It's all gonna be good, okay? So here we go. We're gonna solve each quadratic by factoring. This will go on page 45, yes. We're solving these quadratics by factoring. Okay, so the first step is to make sure it's equal to 0. It is. Good job. Then we're going to factor our expression. So I need factors of negative 36 that add to give me negative 5. And I'm choosing to factor this way because I have 3 terms, and my coefficient of x squared is just 1. Factors of negative 36 that add to give you negative 5. 4 and negative 9. You guys got to that one way faster than I did. All I could think was 6. 6 and 6. I was like, I don't know. Oh, good times. All right, so this is going to factor x plus 4 times x minus 9 equals 0. Then you set each set of parentheses equal to 0 using that 0 product property we talked about, that hot pink piece of paper that Jonathan thought he was colorblind for.
I am colorblind.
I think he is colorblind.
Oh.
That's why he couldn't find the color.
That makes so much more sense. Okay, so set each one equal to 0. X plus 4 equals 0. X minus 9 equals 0. And then solve for x. This one's going to have 2 real solutions because I factored it. I'm going to have 2 answers here. So if I subtract 4 from both sides, I get x equals negative 4. With this one, I'm going to add 9 to both sides to get x equals 9. Okay, try that next one without me. How many solutions did you get? Should be just one.
Would you be an x plus 5 squared without it? Or like, but then you do the negative 5.
Right, you would just get -5 twice. But you don't have to write it twice. It's just one solution.
No, because like I just get x plus 5 and c squared.
Yeah, that's fine. Like this.
Yeah.
That's normally how I'd have done it too. I just didn't want to take the time to write it.
Okay.
And then I wrote it. I know. Okay. Part C. Can I factor it that same way? No, why not? Because there's a 5. Oh no, what do we do when there's a 5? It's not divide. Okay, there's not a GCF, so I'm going to do the 5 times 6.
No.
I mean, I would guess and check if it were me, but you guys hate it when I do that, so I'm going to multiply 5 times 6.
I hate guessing check. Guessing check is so awful.
That's why I'm saying I would multiply 5 times 6. Okay, so factors of 30 that had to give you -17.
15 and 2, negative 15 and
-15 and -2.
AC method's kind of fun because it's like a puzzle. But I only guess and check because that's too hard of a puzzle.
Puzzle has too many pieces. All right, so we're going to do 5x squared minus 15x minus 2x plus 6 equals 0. Right, because you take your middle term and you split it into those two factors you just found. Then you're going to group them 2 and 2. It's all coming back to you now.
I remember this was fun. I liked it. That was it though.
All right, GCF in your first group is what? 5x.
You know what? I'm done. I'm like delete now.
When you divide that out, you're left with x minus 3. There's that 3 you were talking about. What's my GCF in the second group? I'm going to take out a -2, so I can have a positive x minus 3. So this is going to factor x minus 3 times 5x minus 2. Okay, but way back when we just did factoring, that would be your answer and you'd be done. But now we're solving with factoring. So I get to take each factor and set it equal to 0. So x minus 3 equals 0. And 5x minus 2 equals 0. So x equals 3. That one's easy. How do I solve this equation? Add the 2 to get 5x equals 2. And then divide by 5. And x equals 2/5. Ew. Okay, part D.
Sounds okay.
Okay, why is this one different than all the other ones?
Because it's not set to 0.
It's not equal to 0, so we got to get it set equal to 0. So I'm going to subtract x and subtract 8 from both sides. So that's going to give us 12x squared plus 6x minus 6 equals 0. What do you always take out first? GCF. Please don't multiply 12 times -6. Okay, so I'm going to take out a 6 as my GCF to get 2x squared plus x minus 1. Now that you remember how to do AC method, because we just did it right here, I'm going to let you go ahead and factor this with your AC method or guess and check what's left in the parentheses. Just ignore this 6 for a minute and then factor. So hopefully when you factored it, you have x plus 1 times 2x minus 1. Okay, but again, I'm not done because I have to solve it. All I've done is factor it so far. So whenever there's a GCF in front, you actually have to set that equal to 0 as well. So I'm going to do 6 equals 0, x plus 1 equals 0, and 2x minus 1 equals 0. But does 6 actually equal 0? Nope, so just put a line through it. It's not equal to. When you solve the middle one, you're going to get x equals negative 1. And then 2x minus 1 equals 0. You would add 1 first. 2x equals 1. Divide by 2. And x is 1/2. What? Yes. Yes. Okay, part E. How do I factor that one? 3x squared plus 5x equals 0. That's the first thing you always look for. Greatest common factor. Do I have one? X. So I'm going to take out an x, which leaves me with 3x plus 5.
Can we just solve it like that?
Yep. Now it's factored. So you can do x equals 0 and 3x plus 5 equals 0. See, y'all thought this was going to be hard. Okay, that first one's already solved for you. X does equal 0.
Oh. How do we know x equals 0?
Because it's your GCF. It's one of your factors. So you set each factor equal to 0. This one's just already solved. Yeah, don't do that. Because x can equal 0. Here you would subtract 5 to get 3x equals negative 5. Then divide by 3 to get x equals negative 5/3. Yeah, it's a fraction. Okay, part F. Okay. The way we've been doing things, you're probably like inclined to go ahead and add 7 and then square root both sides and solve it that way.
Oh, I was gonna add the 2 minus subtraction 29.
Well,
Oh,
you're on the right track there too. Okay, so you could add 7, square root both sides, solve it that way. That would be solving by square roots. But this says solve by factoring. Okay. On the test, it's just going to say solve, so you can solve it however you want to. All right. I'm going to show you factoring because I think some of you need some factoring refreshers. So I'm going to subtract 29 from both sides to set it equal to 0. So I'm going to get x squared minus 36 equals 0. Okay, it's 2 terms, which means it's difference of 2 squares or dots.
Yeah, double dots.
Yeah, remember the double dots? This one's only a single dots. Okay. Perfect square, perfect square. So we're going to square root them. And then you're going to have one factor that's a plus and one factor that's a minus.
Then it's double dots.
Nope.
Why not?
Double dots is when it factors again.
Oh,
When these in here are both difference of 2 squares.
yeah, I can't remember that because my brain is.
But you remember double dots. All right, so now it's factored. Set each one equal to 0. You're still going to get x equals plus or minus 6. We just did it a different way. And then we will pick up there next time. Okay?
Why do we never have time in class? We have like a whole lesson
Well,
plan and then we're like, we're not doing it.
Well, we took a quiz, so that took a little bit of time. And then these, I need to spend more than the 7 minutes I have teaching you these. So,
Okay,